All right, so looking at standard deviation in a real life context, we're going to look at interpreting it, but also interpreting the mean. So I just wanted to take a look at these two graphs. It says these two graphs show the data collected for the number of raisins in a cereal with a name brand and the generic version of the same cereal for several boxes. What is something that we notice? What is something that we wonder? So this one, if you can't read it, is the name brand cereal. So like Raisin Bran, I guess. And then this is like a generic one, like a store brand. So what's something that we notice looking at the graphs, looking at the numbers? Here says the mean is 289.1. Standard deviation is 19.8. The mean here is 249. The standard deviation is 26. Anything you notice, anything you wonder? Marvin? The second one's more spread out. Okay. So that would be the generic cereal. It's more spread out. Anything else we noticed? It looks like it has less on average. This one looks symmetrical, so that's the name brand one. Is this one symmetrical? Is it close to symmetrical? Yeah, it just has one bar instead of two bars, right? So it's approximately symmetrical. Definitely looks more symmetrical than skewed. So they both appear to be symmetrical. How did you determine that this one has less on average? So the peak here was between 240 and 250 and the peak here. So comparing the peaks. Anything we wonder? I might wonder why is that rather the second one more spread out? Why a raisin cereal? Have you had Raisin Bran? It's a really bland cereal, so I think the raisins are like to spice it up a little. You know what? Right, so that's cornflakes. I thought the frosting part, right? So it's probably just to balance it out to make it taste better, honestly. Okay. Did you notice that the number line at the bottom is the same? So this one is shifted more to the higher numbers too. Okay, so what we're going to do is we are going to look at a couple different graphs, and we're going to look at interpreting the mean and the standard deviation. So you've seen on multiple questions, quiz questions, things like that, I'll say like interpret the blah 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 in the context of the question, right? So we're going to first do some notes about what that looks like. We're going to take these two examples that we just looked at with the raisin cereal. We're going to put these into our notebook right after that calculator page that we did yesterday. So we're going to cut it down the center. Put this one on page 62 and this one on 63. And then we're going to look specifically at the mean number and the standard deviation number for each one and then talk about like what they actually mean when it comes to looking at raisins and cereal. All right, so let's take a look. So same scenario, number of raisins in a cereal with name brand and generic version of the same cereal. So looked at several boxes, they collected data. This is what we have. For the first one, for the name brand cereal, we want to interpret the measure of center. So remember, a measure of center is something that talks about the middle of the data. So it's our mean or our median. In this case, they gave us the mean. So we want to interpret the mean. So what does that 289.1 mean about this cereal box and the raisins? We want to write a sentence about what it means because it says interpret it in the situation. So 289 what? What do we think that number represents? Yeah, number of raisins. And so if it's a mean, what does a mean calculate? The average. So we can say on average, there are, yeah, so you can say 289.1. You could probably also say like about 289, right? Because probably going to look at whole numbers of raisins, but on average, there are about 289 raisins in what? In a box of brand name cereal. So you should be able to expect, if you bought a brand name cereal box, whatever brand this is. Sorry, I can't write cereal. I always mess that word up. That you'd have about 289 raisins in that box. Yeah, well, it doesn't matter how you glue them in, but yeah. So mean tells us an average. Median also tells us an average. It's not a mathematical average, so it's a little bit different. It's more like a middle average, just a middle number. So mean is more appropriate when we have symmetrical data. And one of the things we noticed is that the graph was symmetrical. So that's why we're using mean and standard deviation. The second part is we're asked to interpret the measure of variability. So mean is our measure of center. The measure of variability is something like standard deviation, NAD, IQR, depending on what your data is. It's symmetrical data, so our measure of variability in this case could be MAD or standard deviation, but they gave us a standard deviation, so that's what we're going to focus on for this one. So the standard deviation is 19.8. So what does that 19.8 tell us about these boxes of cereal? So yeah, if we were looking at a group of boxes, most of them would be within that number from the mean. So they might be about 90, well, it's about 20, right? 19.8, about 20 raisins more than the mean or about 20 raisins less than the mean. So we can say, in general, most of the boxes, or we can expect a box to be in that range of either 20 more or 20 less than the mean. So a box of this brand name cereal would be expected to have somewhere between 20 more or 20 less than the mean. Many less raisins than the mean. We could actually calculate the range if we wanted to and say, what's 289 plus 20? What's 289 minus 20? And say, the raisins in most of the boxes are going to be about 269 to 309 based on the standard deviation. So it gives us a little bit of a range to say, generally, they're in this range. They're not all going to be exactly where the mean is. That's just the average. But they're also not going to be super far away from the mean. It's going to be about 20 less or 20 more. So it gives us a way to say, like, how different can you expect a box to be from the mean? And is it going to be a lot different or a little bit different depending on what the standard deviation is? So 20 more or less when you're looking at a whole box really isn't that much. 20 raisins could easily fit in like your hand. It's not a lot. And we want to see when we look at the generic brand, if that says the same information, different information, we'll want to look at how it compares after we interpret each piece of that as well. You might even be able to look at the first question, interpreting the measure of center for that one. And you might even be able to write a sentence before we get there based on the one we just did. So looking at the generic brand of cereal, it's also symmetric. So you'll notice they also use mean and standard deviation. You're going to want to use the same if you're comparing them anyway, because you want to compare mean to mean and standard deviation to standard deviation. But what could we say about the measure of center for that one? Yeah, so there's about, so it's important to say the word about or around, like you said, because we're not using the exact decimal. And because it's a raisins, you can't really have 0.17 of a raisin. You can say about, but just make sure you use that since it's not an exact number. It's about 249 on average, 249 raisins in that generic cereal box. All right, so he said there are around, on average, there are around 249 raisins in a box of generic brand cereal. That makes sense because generic is usually cheaper. So it would make sense to me that they would put less raisins in there. So they can make it cost a little bit less. Right? If we want to interpret our measure of variability, our standard deviation for this one, it's 26.35. So what can we say for that? A box of this generic brand cereal would generally have what? Generic brand cereal. So a box of generic brand cereal would generally have 26 more or 26 less raisins than the average, which is 249 for this one. So this one would be expected to have like 224 or 223 up to 275. So that would be the range. So if we're going to compare the two, what can we say that we've noticed looking at the average and looking at the spread? You said what? Pretty similar. Okay. So what, is there something specific we can say that's similar about it? Or different? They're not way off, so that's good. That means the generic brand is probably competing pretty well with the name brand. So we have less raisins in the generic one. So we can say that's a comparison, right? On average, the generic brand has less raisins. So that's a comparison of the means. The generic brand has less raisins per box. Actually, it's 40 less if you do the math. So I'm going to put that in there. It's 289 minus 249. So 40 less. And then you said something about the spread being different. So one of them was 26 and the other one was, yeah, it has more. So generic brand has more of a standard deviation. So what does that mean about the consistency of their boxes? Yeah, it's less consistent than the name brand. So the name brand is going to be whatever box you get, you're more likely to have the same number of raisins in it, or at least close to the same number. This one's a little bit more variable. So you may get a box with a lot more or a box with a lot less because they're not as consistent. So we can say also, because the standard deviation is higher, just going to abbreviate SD for standard deviation. The number of raisins in the generic brand is not as consistent as the name brand. I'm going to run out of this box because I don't have enough room. And I guess if you're thinking about whether you buy name brand versus generic brand, a lot of people go, some people go, I always want the name brand because they want something like that's more consistent. If I buy a box, I want it to have the same as if you buy a box. Somebody else might say, I'm just going to go for whichever one's cheaper. Really doesn't matter to me. Tastes the same pretty much, whether I have 5 or more. A difference of 5 or difference of 20 raisins isn't going to make a difference. So now you're going to look at 2 other sets of graphs. You're going to interpret the measures of center, interpret the variability, and make a comparison statement. So we've got 2 dot plots on the front about the heights of 40 trees. And then you've got 2 dot plots on the back. No, it's just practice. About time to finish a test. So we're practicing Criterion D, which is interpreting these statistics that we're calculating. What do they actually mean in this real life situation? It's our Criterion D practice. All right, so just finish up that 13.3, those 2 examples of interpreting. And then I will see you when I see you. Have a good day.